Hi GOR, this is Unit 3B and it's the last lesson, lesson 7. So today we're going to talk about proofs involving parallelograms. So I saved the best to last because I know that you guys love to do proofs. So first we're going to talk about how do I prove a quadrilateral is a parallelogram. There are 3 different ways you can do this, and this is frequently a multiple choice type question on the Regents. To prove a quadrilateral is a parallelogram, you must show one of these 3 things. You are either going to show that both opposite sides are congruent. What does that look like? That looks like, here's my parallelogram. These top and bottom are congruent, left and right are congruent. If you can show that, then it's definitely a parallelogram. Or you're going to show that both opposite sides are parallel. What does that look like? I'll do that over here to the left. So if the top is parallel to the bottom and the left is parallel to the right, then it's definitely a parallelogram. And that makes sense because that's our definition of parallelogram. Or if you have one pair of opposite sides are congruent and parallel. So if you have one pair of sides, and I'll use the big diagram. So say the top is congruent to the bottom and the top is parallel to the bottom. That's the last way that I can prove that something is a parallelogram. But it has to be the same set of sides that are congruent and parallel. So what would not work? This does not prove parallelogram. And this is what they ask on the Regents all the time. So if you have one set of sides congruent and a totally different set of sides parallel, that will not prove it's a parallelogram. Okay, so this will not work. They either both opposite sides are congruent, both opposite sides are parallel, or you have one set of sides is congruent and parallel. The reason the one up above doesn't work, think of this figure. This figure is called a trapezoid. And if these 2 sides are congruent, it's called an isosceles trapezoid. So an isosceles trapezoid has one pair of opposite sides congruent and it has one pair of opposite sides parallel, but that is not a parallelogram. Okay, so in the first proof that we're going to do, we're going to prove it's a parallelogram, and in the second proof, it is a parallelogram, and we're going to use the fact that it's a parallelogram to prove that the triangles are congruent to each other. All right, so first one, I start with my given off to the left here. So I'm going to write small, so I left out statements usually get written and reasons. I left that out. So I got to squeeze this all in. This is going to be 7 steps. So DB bisects AC. DB bisects AC. So DB right here is bisecting AC. And I got to add one more thing into my given. Angle 1 is congruent to angle 2. All right, so if you guys add that into your given, I forgot to write that when I typed it up. Angle 1 is congruent to angle 2. So angle 1 is congruent to angle 2. Boom, I'm writing it already. And DB bisects AC. AC is the thing being cut in half. A bisector divides a segment into 2 congruent segments. So I'm bisecting AC. Go to AC. Look how I just traced it with my pen. It's being cut in half. So now you're going to say what is congruent to what. The left half, AE, is congruent to the right half, EC. How do I know that? It comes from the statement above. I had a bisector in my given, so it's just definition bisector. Okay. Now, I'm going to put some numbers in here. Angle 3 and angle 4. Okay, so I got angle 3 and angle 4. Those are vertical angles. Angle 3 is congruent to angle 4. Now, I haven't really told you the plan right yet, but what I'm going to do is I'm going to prove that this triangle on the left that I'm highlighting in yellow is congruent to this triangle on the right. And then I'm going to use the corresponding parts to prove that those opposite sides are congruent and those opposite sides are parallel to each other. All right, so angle 3 is congruent to angle 4 because they're vertical angles and vertical angles are congruent. I now have enough to say that my triangles are congruent. So the 2 that I have highlighted, triangle ADE is congruent to triangle CBE. Look at what's marked. Look at your picture. I have an angle, a side, and an angle. Now, since my triangles are congruent, all the corresponding parts are congruent. So I'm going to do the rest of this in red. So that means that AD right here, the left side, is congruent to BC, the right side. So AD is congruent to BC. Why? Because they are corresponding parts of congruent triangles are congruent. The triangles are congruent, so the rest of the corresponding sides and angles are congruent. I already know that angle 1 is congruent to angle 2. That makes AD parallel to BC, because angle 1 and angle 2, if you want to turn your paper sideways, are really just alternate interior angles. So since the alternate interior angles are congruent, angle 1 and angle 2, right here, I'll do them in red. Since they're already congruent from the given, then that makes AD parallel to BC. Since I have one pair of opposite sides that are both congruent in step 5 and parallel in step 6, then that makes ABCD is a parallelogram. And why? One pair of opposite sides are congruent and parallel. One pair of opposite sides, meaning the AD and the BC, are congruent and parallel. Perfect. Now the next one is completely the opposite. In the next one, the given is telling you it's a parallelogram. So anything that's true about parallelograms you can use as a statement. I'm trying to prove that my triangles are congruent to each other. So I want triangle LGS. That's this one right here. I'll highlight it so you can see which, because I got 4 triangles going on. I want to do LGS is congruent to HAF. All right. So I'm going to start again in purple. I got my statements on the left. I have more room here. I got my reasons on the right. You'll have plenty of room always on a test or a Regents. So FLSH is a parallelogram. And FS is perpendicular to LG. And FS is perpendicular to HA. As soon as you're reading the fact that they're perpendicular lines, you know that there are right angles in there. Okay? So if we want to start with that, we certainly can. I'm going to put some numbers onto my picture, and I'm going to call these angle 1 and angle 2. Remember, I'm trying to prove those green triangles congruent. Those lines are perpendicular. It was already marked on your picture, but I need it to be in my proof. So what do I say first? As soon as I have perpendicular lines, you know that that makes right angles. So I'm going to say angle 1 and angle 2 are right angles. How do I know? Because they're perpendicular. After you say that they're right angles, you know that all right angles are congruent. If they're both right angles, that means they both equal 90. They have to be equal to each other. So I just simply say angle 1 is congruent to angle 2. All right angles are congruent. All right, so I got an angle. I got angle 1 and angle 2. They were right angles. I'm just going to draw that bigger. Now this is a parallelogram. Since it's a parallelogram, that makes opposite sides congruent. So LS is congruent to FH. The top is congruent to the bottom. Is the left congruent to the right? Absolutely, but those aren't the triangles that I'm trying to prove. Okay, so those sides wouldn't help me. It wouldn't be wrong to write, but they wouldn't help me. Now, besides those sides being congruent, the reason is opposite sides of a parallelogram are congruent. Besides those sides being congruent, a parallelogram also has opposite sides parallel. You might say, well, why is that going to help me? You're going to see in a second. The reason is opposite sides of a parallelogram are parallel. This one you could actually write definition parallelogram, because if you remember, that was our definition back when we started this unit. But otherwise, opposite sides of a parallelogram are parallel. Wonderful. So these sides are parallel. How does that help me? I'm going to call this angle 3 right here, and I'm going to call this angle 4 right there. Those are alternate interior angles. So if I know the lines are parallel, then that makes those angles congruent to each other. Angle 3 is congruent to angle 4. Alternate interior angles are congruent. Okay, and now look what I have. I have an angle, and a side. Now I can say that those triangles are congruent to each other. Triangle LGS is congruent to triangle HAF by angle, angle, side. All right, so two types of proofs. The first one, I had to prove it was a parallelogram, and the second one, I knew it was a parallelogram, so I used the property